Hi folks, so I wanted to show you another example myself of graphing a piecewise defined function. So here I have f of x, which is defined in three chunks, three pieces. The first piece is negative 2x minus 3 for x's that are less than or equal to negative 1. From negative 1 to 3, the open interval, I have my function is defined by x squared. And then from 3x for x is greater than 3, my function is just equal to 4. So again, the way you can think of this is just think about reading it from left to right. So I'll draw this first part in green here. So the graph 2x minus 3, well, I could just draw that based because we know what a linear function looks like. So it's got a y-intercept of negative 3. So that'll be down there. Draw it in there, negative 3. And it has a slope of positive 2. And so this would normally just look like so. Try to line it up from here. So it's going to look something like that. However, because this is a piecewise defined function, we are not using this green line for the entire graph. The only parts we use the green line for would be right here for x equals negative 1 and below. And so really, this green line, I'm actually going to have to erase it. Let me put that back. Let me erase that. We're actually not start using that green line until, or sorry, if I read left to right, I'm using that green line all the way up until I get to negative 1. And so this is what this first chunk of the graph is going to look like. On these piecewise defined graphs, it is really important to notice the endpoints. And so this one will, first off, there is no endpoint on the left side. And it goes up until negative 1. So I'm going to emphasize that by putting that point there. And once we get to this next part, then you'll see why that's useful. Because now, once I get to, negative 0.999, I suddenly jump into the x squared graph, which I'll use red for. And so at negative 1, remember, at negative 1, you're still on the green graph. But to indicate that we are jumping, I'm going to draw, we'll start off by drawing x squared. So the graph of x squared looks something like this. All the way up. Something like that, right? But again, does not start until we get to negative 1. So at negative 1, which is right here, that point is going to have an open point on it. Again, that is because f of, and I can write this here, f of negative 1 is on the green graph. So maybe I should write that in green actually. F of negative 1 is actually equal to, well, what would that be? Negative 5. Because again, it's on that linear piece. But as soon as we jump over negative 1, now we're on this quadratic piece. So let me now erase this piece of the graph. And the question is, how long do we follow this parabola? Well, we're scooching along the parabola until we get to x is less than 3. So basically up until 3. And so that point right here, that'll be, let's see, 1, 2, 3. Well, 3 squared would be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to be right there. And so that red piece is going to be how our graph in that middle chunk. All right, the last part now is the third piece, the constant piece. So I'll do that in blue. And let's see, for x greater than 3, our function is just equal to 4. And so let's see, 1, 2, 3, 4, be right there. And since, remember, 3, 4 is actually not on the graph, right? Because again, this is saying for x is greater than 3, strictly greater than. And so I would signify that by starting off at 4 and going off to the right side there. Notice here, this means that my domain of my function, the domain of our function is all x values except for 3. Because if you were to plug in 3, this function has no idea where to put it. Right? I know what happens if x is less than 3, and I know what happens if x is greater than 3. But at no point in here does it tell you what to do if x is equal to 3? So that's an example of taking a piecewise function and graphing it. Again, this is really important. Like, this is easy, it's provided you know what these functions look like. Alrighty, but if you don't, that's something to work on. Alrighty, catch you in the next one.